My name is Kazuhiko Yokoji. I'm a manager in CAE and Material Department of Nabtesco Corporation. I'm responsible for conducting analysis and educating engineers and maintaining CAE systems for all groups in my company. At Nabtesco, we produce motion control equipment such as reduction gears and flight control systems and oil motors for earth-moving equipment. The biggest challenge in the wind energy industry for Nabtesco is make sure of sufficient gear strength and endurance, long-term endurance in gusty conditions. I think top two technical requirements for realistic simulations are the motion reproduction and FSI. Our reduction gear are a lot of very complicated assemblies with many conducting parts. This kind of analysis was very difficult, but it is essential so that we can develop gear motion and estimate the gear performance. FSI is indispensable for analyzing the effect of wind velocity and gusting and structural vibration. We choose Abaqus because it gives us the true physics of various problems. We produce the RV gears, very complicated assemblies that have a very complicated movement over the long travel distance. In addition, attaching the motion detection devices would influence the movement, and so obtaining the valid experimental data is very difficult. Abaqus bypasses these problems and allowed us to grasp what is going on inside the components. Right now, we are focused on the topics of optimizing wind turbine gears engagement. So, in conjunction with Abaqus, we use Isight for design optimization and post-processing automation. It is amazing how many man-hours this saves us. The key features that made us choose Abaqus, the combination of implicit and explicit dynamic analysis, and recent improvements in Abaqus standard. The pinion is a gear which connects our ring gear with our RV gear for yaw or pitch drive. The pinion gear repeatedly rotates and reverses in a very small angle. To prevent gear damage, the contact area must be increased and the maximum stress decreased. And optimizing the gear shape can achieve this goal. The realistic simulation has the advantage of enabling us to simultaneously analyze the contact area and high stress, maximum stress using a finite element method and our newly developed user subroutine. To calculate the maximum stress on the gear tooth, the mesh had to be very fine, which increases calculation time. To avoid this problem, submodeling analysis was used. In the normal analysis, stress on the gear tooth accurately can be analyzed, but total contact area cannot be analyzed. So, the newly post-processing technique that shows the history of stress on the tooth was developed using Abaqus user subroutine. Using our innovative analysis and evaluation technique was developed, allowing simultaneous analysis of contact area and maximum stress during an entire history of engagement. We have confidence in our analysis results because we compare the area and the shape of contact region to actual test data. And the agreement is very excellent. So we plan to apply this technology in the design phase of production. Realistic simulation save our company time and give us confidence that we are delivering our best product possible to our valuable customers.